right, AP Calculus AB. We're going to find the volume of a solid generated by revolving the region bounded by y is equal to the square root of x, y is equal to 0, and x is equal to 4. And here's my beautiful little picture here. And we're going to do something different right now. We're going to revolve this around the y-axis. So what we're going to do here is this, in essence, is that we're going to spin this thing. Here's the line about which we're going to spin it. So this is a little post, and this is a little post driven through here. We're just going to spin this thing around like a child's toy. And as we do, when we get to the other side, it's going to look like a reflection of this. But what I want to make sure you are getting is that it's not just going from here to here. It's going around. It's going... right? It ends up looking like a bowl, doesn't it? It ends up looking like a bowl. So, and this bowl is dug out, has this dug out spot in the top, in the middle of it, isn't it? So hopefully you can see that. Because this is not solid, like here's a solid circle, right? Here we could just use the disk method, because if I'm suggesting to you that this thing is solid all the way through and it's not dug out at all, then we can just use the disk method. This one is dug out, right? So it's dug out in here, and it does this weird thing, right? So it has a hole. You could pour, I don't know, cereal into it, I guess. Not much cereal, but you could pour cereal into it. So this is what we end up doing. We're going to use this washer method. This washer method here. This is how the washer method usually looks, but because we're using the washer method because this thing is dug out. Point number one. However, we're going to have to change this. We're going to have to adapt this washer method a little bit because we're revolving it around a vertical line. So this is revolved around a horizontal line. So all we're going to do is just change it. That it's pi times the definite integral. I'm still going to use a to b, but it's not really a to b. You'll see why in a second. And it's not, right? It's not r of x anymore. Now it's r of y, right? Because the pieces we're going to be taking are these pieces right here. We're going to take the volume of these pieces here, right? So we're going to take the volume of that, please, minus little r of y squared. And of course, instead of being dx, we'll be in dy. All right? So now what we have to figure out is, what is the radius of this circle? How would you determine the radius? Well, what I'm going to do first, I'm going to look at something that's really obvious to me. And what's really obvious to me is that the radius starts, the biggest possible radius we're going to have is 4, isn't it? Because we went from 0 to 4. So 0 to 4 has a distance of 4. So that's what I'm going to say here. I'm going to say that the volume is equal to pi times the definite integral. But we're looking at this thing as it spins around here. So we're looking at changes in y. So the starting height is 0. The maximum height is this 2 right here. So we're going from 0 to 2. Hopefully that makes sense to you. And now I'm going to start with the radius. What is the radius? Well, the maximum radius is 4. But look, the radius keeps getting smaller, doesn't it? This line, this pink line, I'm sorry, this pink line is shorter than this one. This pink line is shorter than the 200, etc. Well, how much shorter? So we have to take off part of that 4. Well, the part we need to take off is the y squared part, right? So hopefully that's making sense. But remember, it's, right, remember, it's, okay, I think we're good. Hold on one sec. Okay, you guys, forgive me. I kind of blew it for a second there. Because this radius here is 4, so I have to square it. So this 2 is this one right here. And this radius... Okay, I've officially been interrupted 4 times now, and I apologize. So here we go. This is the outer, this is the inner, right? Because this, we have to carve this out. Remember, we're saying here we're taking this inside, the radius keeps changing, right? So we get here, we get volume is equal to pi, yes, 0 to 2 of 16 minus y to the 4th dy. And from here, this is really good news. Finally, we can integrate here. So I'm going to go ahead and integrate. I have been reminding you guys in every video, make sure you do not lose this value of pi. Make sure you keep dragging along with you, because it's what changes the area here to the volume. I'm sorry. It's part of the volume, right? This times this times this is the volume. So we integrate this, so it will be pi times 16y, right, minus 1/5 y to the 5th as evaluated from 0 to 2. And here, we can, if you want to, just use the fundamental theorem of calculus here, which is just the f of b minus f of a is the area, isn't it? And all we have to do is remember to multiply by pi here, and this can really work out good for us. Works out great here because we don't have to evaluate the a part, because in this integral it would go to 0, wouldn't it? So this thing ends up going to, it goes, right, 16 times 2 minus 1/5, 2 to the 5th, right? 2 to the 5th is 32, isn't it? 32. So we have 32 minus 32 fifths. I'll multiply this. Oh, remember, oh my gosh, you guys, remember, keep bringing that pi value down there. You'll get in trouble. 32 times 5 is 160, so 165ths is equal to 128 pi fifths is the volume. Okay, I hope this was helpful. You guys got to know how to do this. You're definitely going to see this on the AP exam, so we just have to practice and plug along and go on and on. I know there are going to be questions and comments, and I look forward to them. Don't worry about hurting my feelings. Keep doing your work your very best, and I'll keep doing mine. Good job, and if you're not subscribed, please subscribe.